Okay, today we're going to talk about cross product. So the cross product of two vectors is a vector that is perpendicular to those original vectors. So the cross product is a vector quantity and it's defined only in 3D space, so it will have its own direction. So let's say we have vector A and vector B. The cross product of this vector, A cross B, is this kind of complicated looking equation to represent the x or the y coordinate times the z coordinate of B, take away the z coordinate of A times the y coordinate of B, and that's your first vector, and so on. And while this is true, there is actually a simpler way to find this. So what you do is you write out A 1, 2, 3, 1, 2, 3, and underneath you write out B 1, 2, 3, 1, 2, 3, and then you disregard the first and last set of terms, and then A2 times B3 is this, and then you're going to take away A3 times B2, which is that, okay? And then the second coordinate is A3 times B1, which is this, and then you take away A1 times B3, which is that. The last one follows the same pattern. It's A1 times B2, so A1 times B2. And then you take away A2 times B1. Okay? And then the product of that algebra is the value of the coordinate in that position. Okay, so let's look at an example here. So we're going to find the vector that's perpendicular to both vector 1, 3, 2 and also vector negative 4, 6, negative 2. So what I'm going to do is I'm going to write out these two vectors. 1, 3, 2, 1, 3, 2, negative 4, 6, negative 2, negative 4, 6, negative 2. And now I'm going to disregard the first set. And I'm going to do A2 times B3, which is negative 6. And then 2 times 6, which is 12. And that's my first coordinate. And I can figure that out right now too, just to kind of track and keep going with it. And then I can do 2 times negative 4, which is negative 8. So that's A3 times B1. And 1 times negative 2, so take away negative 2. Negative 8 take away negative 2 is negative 6. And my final coordinate is 6 times 1. Take away 3 times negative 4, which is negative 12, which will be positive 18. And from before, we can remember that we can have a scalar quantity k, and so I can actually factor out negative 6 or positive 6, doesn't matter, and be left with 3, 1, negative 3 as vector v. And this vector with any value of k here, this is what's saying up here, will be perpendicular to these two vectors. Okay, so if A cross B is V, then A dot V equals 0 and B dot V equals 0, because whenever we take the dot product, we're going to get 0 if those two vectors are perpendicular to each other. So we're going to check our resulting vector up here to make sure that that's true. So we're going to just remind ourselves that A is the vector 1, 3, 2, and B is the vector negative 4, 6, negative 2. These are just from the question above. And V is the cross product of A and B, and we found that to be 3, 1, negative 3. And now we're going to check, and we're going to see what A dot V is, because this is how we can check our work. Okay, so in order to do dot product, remember we're going to do 1 times 3 plus 3 times 1 plus 2 times -3. That's going to give me 3 plus 3 minus 6. That does equal 0. These vector A is perpendicular to vector V. And we might want to also check for B dot V. Do the cross product here. I'm going to have -4 times 3 plus 6 times 1 plus -2 times -3. -12 plus 6 plus 6. That also is 0. Therefore, B is also perpendicular to V. Okay. There's also a rule that we can follow here, and we can talk about the magnitude of the cross product of two vectors A and B, and we can have this notation or this rule to remind us of that A cross B is the magnitude of A times the magnitude of B times sine theta, where theta is the angle between the two vectors, and that angle also needs to be between 0 and 180, so that's the related acute angle. And this is really similar to the magnitude of the dot product. Okay, so how do we figure out which direction we want our resultant vector to go? And so this, in order to picture this, think about turning a bolt, or actually really just waving your hand or moving your hand from two vectors, from one vector to the other, and the direction of the cross product will be the direction of your thumb. So, okay, so what I mean is, okay, let's look at this first set here. Okay, so let's say I'm going from U to V. I want to go U cross V. So if I put my hand along U and then I move it towards V, the direction of my thumb is up and out of the page. So this first one is up, however you want to think about it. Okay, so I could maybe even try to draw it in there. So this guy kind of goes up like that, and that's perpendicular. Okay, and then let's look at the other example. Let's say I'm going U cross V, but these are my two vectors. So now I'm going this way. And so now in order to move my hand, my fingers from U to V, I actually have to turn my hand over. And this vector is actually going to go down. So this vector goes down or into the page, whichever makes more sense to you in your brain when you're trying to visualize this. Okay, so let's look at an example where we're going to apply our sine rule. So the magnitude of U cross V is equal to the magnitude of U, magnitude of V, and sine of the angle in between. And so I've already been given these two magnitudes. I don't actually have the vector, I just have the magnitudes of the vectors, 6 and 8, and sine of 30. And so I'm just going to calculate this. To 6 times 8 times sine 30 is 24. And then I can think about, here's my 30 degrees. And so I'm going to think about going this way. And I'm going to think about how my hand is going to come up out of the page. Okay. These are just some other properties. They kind of follow the same rules that you would expect. So the directionality, if we do A cross B, that's very similar to B cross A, except the direction's been flipped. A cross B can also follow, or times B, A cross B plus C, excuse me, can also follow like this distributive property. So it's also the same as A cross B plus A cross C. So this is a good one to remember. And this scalar multiplier, it actually doesn't matter when it is applied. So you can do A cross B and then multiply by your scalar, or you can multiply the scalar by A first or the scalar by B first. Okay, some other things to consider here are the products of the unit vectors, I, j, and k. So in this set, these vectors are parallel to each other. Well, they are the same. And the angle between them is 0. And sine of 0 is 0. So these guys, the cross product here is 0. But let's look at this example a little bit more closely. So let's look at I cross j. So I is the vector 1, 0, 0, 1, 0, 0. I'm going to write it out. And then here's j. And now I'm going to do the cross product here. So get rid of the first terms. So 0 times 0, 0 times 1. My first term is 1. 0 times 0, 0 times 1. Second term, or my second coordinate is 0. 1 times 1, take away 0 times 0, my third coordinate is 1. And this is the k vector. Let's do another one. So the j vector, the k vector. Let's take the cross product. 1 times 1 is 1. Take away 0. My second term is 0 times 0, and 0 times 1, so that's 0. And my third term is 0 times 0, and 0 times 1, so it's also 0. And this is my I vector. And this makes sense because, if you remember, my I cross my j is the k vector, and that is my other axis. And then my j cross the k is my I vector, or my I coordinate. Okay, so I cross k must equal the j vector. Okay, so spend some time just thinking about these ideas. Do the practice problems. Try really hard to pay attention to what you're doing and thinking about why you're doing what you're doing.